I'm gonna pull these ones.
Okay, I'm learning a lot this week. One of the things is not to have anybody run the microwave while we're doing this. I'm getting some interference to our Wi-Fi, and that killed the stream. So I put the link back up to this. I hope people can find it. This is kind of tedious, but I did put up a new announcement with this link. Hopefully people can find this one also. We're on part 2 for the 26th, doing a little review for this test coming up. I'm going to get back into the context of what we were just trying to finish up. All right. We'll see how this goes here. We can get back into the problem we were working on now, hopefully. That was the conclusion of it. I wrote this up as the other thing was dying, so I don't know how much of this you got. Is this going to be kind of readable? We got written as a single logarithm. There, that's fuzzy. Log of x squared over y to the third times the square root of 6. That's what you should end up with when you get all that put together. So that's using the logs of these things. Property says when you have subtraction here, it turns into division. And when you have addition here, it turns into multiplication. So that's what we got. You could combine some stuff in there a little bit, but that's the single logarithm. Notice that I didn't put a base on that all the way through. So I was dealing with log base 10 there, but it didn't really matter what the base was. As long as they're all the same base, you can use all of these properties, and it doesn't really affect the base. We don't mix different bases generally. So as long as they're all the same base, you can do all of the combining and taking apart without messing with the base there. Now we can take things apart using these properties too. Looking back at how this was worded here, because I'd like to do one of kind of the opposite process on that, writing that separately. If we've got something like the log base 5 of 100, minus log base 5 of 4, you see how that makes a difference in this process here. This is again starting off as two separate things and working to get a single logarithm, but you can see where it might pay off in something like this and how this, we get one more property involved in this thing. We'll be able to simplify this. Now these are numerical, log base 5 of 100 minus log base 5 of 4. Those are just numbers, but they're not nice numbers. You could do this in the calculator. Well, you really couldn't because you don't have a log base 5 button. So you'd have to rewrite it using change of base to do this in the calculator. But it actually comes out nicer if we just use the properties here. In your calculator, you could do this as regular log of 100 divided by the regular log of 5. And the same thing with this one. To change the base to use something like regular log, you have to divide by the old base. So you could separate this out and you get crazy decimal for that, crazy decimal for this one, and come out to a nice number. But it's much easier to do something like this by combining those two things using our properties. That's a subtraction problem. So it's going to turn into division. We'll see where that ends up and why it comes out so nice. More lights. Log base 4 of 100 minus log base 4 of 4. Well, it's subtraction, so that's going to turn into division when we combine these. I'm going to have log base 5 of 100 divided by 4. Now 100 divided by 4 comes out to 25. That's why this is a nice number. 25 happens to be a nice power of 5. So if we write it that way, we can use one other property to simplify this. We get a number that we can write as the power of 5. Log base 5 is asking what exponent do I put on 5 to get this? And what exponent do I put on 5 to get 5 squared? Well, the exponent is 2. This is just 2. Or to phrase that a little differently, the log base 5 and the exponential base 5 are inverse functions of each other. So log base 5 of 5 to the something, you're just going to get this back out. Those are inverses, so they undo each other, and you just get 2 back. So that's where the combining things sometimes can help you simplify something and get a simpler way of writing it.
Tell you in Niagara Mohawk, almost to the high water mark.
Turn the page here and think about exponential equations a little bit. I'm trying to get a mix of the different ideas in here. So we got to review all of it. Exponential equations are part of 5.6. I'm going to take one out of the book here from 5.6. This one's actually part of the homework here, and I wanted to get to one like this. So a little different approach to this one when we have different bases. This is actually number 50 from the homework. I have an exponential on both sides, but they're different bases, and they're not even like compatible things. If I had like a 2 and an 8, or a 5 and a 1/5, or something like that, where I could rewrite them as the same base, then I could try to cancel something. If you can get them written with the same base, you can cancel the bases. But that isn't going to happen with 2 and 5. They're not powers of each other at all. That's 2 to the x plus 1 equals 5 to the 1 minus 2x. I'm trying to say everything out loud also, because I know I don't have the greatest. This might not come across as the greatest imagery here. It's barely readable, I think, but that's what it says. Can't really cancel these things if they're two different bases like that. So we're going to have to approach this differently. And this kind of equation, we just do the log of both sides. You can use whatever log you want. I'm going to go ahead and use natural log because it's easier to write, but something that your calculator can do, because we're going to have to work it that way. So I'm going to go natural log of 2 to the x plus 1 equals natural log of 5 to the 1 minus 2x. You can do this to both sides. You can take the log of both sides. And then your properties tell you something about this, that the powers can be written as multiples. So this turns into x plus 1 times the natural log of just 2. And this turns into 1 minus 2x times the natural log of 5. Now, the natural logs are still in there, but those are just numbers that you're dealing with. Natural log of 5 and natural log of 2 are just numbers. So we can actually just, we just got x terms and number terms, really. I'm going to go ahead and distribute this to both of those. and distribute this to both of those because it's just some number sitting out here. So it's not bad as an equation, it just looks a little funny. Natural log of 2 times x plus the natural log of 2 equals natural log of 5 minus 2 natural log of 5 x. I just have x terms and number terms. And I want to get the x terms on the same side and everything else on the other side. So I'm going to rearrange this a little bit. I got natural log of 2 times x plus 2 ln 5 x. Those are my x terms. That's going to be added on that side. And this will be subtracted over here. So the natural log of 5 minus natural log of 2. That's just a number. And this is really just x times a number if I factor it out. So I'm running out of space. I'm going to shift this up. That's my x term, so I can rewrite that by factoring out the x. ln of 2 plus 2 ln of 5. So writing it that way, we just have x times something equals something, would just divide. So x would have to equal this divided by that whole expression. So it's going to look like, it's going to look crazy, but this is just a number over here. X equals this number. That's ln of 5 minus ln of 2 divided by ln of 2 plus 2 ln 5. Both of those things you could calculate. I mean, you can work out what that comes out to. So let me just run through that because we know how to use a calculator on these things too. I got a strange looking calculator, but I'm going to give this a try. I'm dealing with, and you got to be careful with your parentheses on these things. But ln 5 minus ln of 2. See what that is. I don't want to try to do too much in a calculator at the same time. But that says that this ends up being 0.916. And then we're going to do the denominator separately. ln of 2 plus 2 ln of 5. ln, one of the logs that's actually on the calculator. So these aren't hard to do. It's 3.912. And I could do the division out just to get the numerical. It's approximate solution, but it's the solution to this equation. 0.916 divided by 3.912. .234. Oh, the stream's looking good now. I don't know why that got readable. All right, 0.234 is the solution to that. Now, if you go back and try that out in the original expression, we should be able to get approximately the same number from both of those. That's 2 to the something and 5 to the something. It's not a nice number, but that's the solution. We don't have domain concerns with that one because we started with exponentials. Exponentials have a domain from minus infinity to infinity, so we don't have to worry on this kind whether the solution actually is in the domain or not. There isn't a concern like that with that kind of function. I'm not getting questions on this lately, and I don't want to make these things tediously long. So I think I'm going to wrap this thing up for now. We covered a lot in that. So if you get a chance to get through these videos, I hope that's helpful review on you for you. I'll be mailing out the tests, emailing the tests, to the people either tonight or tomorrow morning, as the case may be. So anything you get stuck on between now and then, email works. There's that discussion group in the Blackboard course also. I'll keep an eye on that. And I'll be getting those tests sent out shortly. Hang in there. We'll get through this together. Thanks for your participation. I'll get those tests out soon.